Welcome to the Edge of Industry, our new podcast dedicated to unfolding how industrial connectivity brings value to your organization by accelerating digital transformation at scale, reducing cybersecurity risks, and unlocking operational efficiency. In today's episode, Steve Sponseller is joined by Brian Zakrasek, Senior Manager for Smart Manufacturing at Deloitte. Together, they'll explore the idea of software-defined manufacturing and what investments are required in OT infrastructure to unlock the potential of advanced technologies.
Hello, welcome to the Edge of Industry podcast. I'm Steve Sponseller, and I'll be your host for this series of conversations with thought leaders as they embrace industrial connectivity to improve operations, reduce cybersecurity risks, and undergo digital transformation. For our latest episode in this series, we were fortunate to have Brian Zakrasek, Senior Manager for Smart Manufacturing at Deloitte, to discuss software-defined manufacturing, the how and why it's helping companies advance Industry 4.0 initiatives. Brian, welcome. We're so happy to have you.
Hey, Steve. Yeah, excited to be here.
Cool. Well, great. Senior Manager of Smart Manufacturing is a little bit of a broad title. Can you give us an overview of your background and specifically what you do at Deloitte to help your manufacturing clients?
Sure. So I grew up as an electrical engineer, deploying process control systems and electrical and instrument systems into predominantly chemical and oil and gas. Did that for about 12 years with some large engineering firms. Moved over to a large automation vendor, Rockwell Automation, for 6 years, worked as both a solution architect. That was sort of where I took my first, I think, significant step into the digital world, moving out of automation and into some of the converged digital solutions. Ultimately ended up leading the North American portfolio for their automation and digital design software segment. Here at Deloitte, I've been here for about 2.5 years, and I specialize really in converged OT and IT, like smart manufacturing programs. And so I lead some of our larger programs across a whole number of different industries: logistics, metals, life sciences. And then I also sort of serve as a lead solution architect for our smart manufacturing practice.
Great. I like how you started off saying you grew up as an electrical engineer.
I still think I'm trying to figure out what I want to be when I grow
yeah,
up. So
I'm still growing up too. Yeah. So Deloitte is certainly a household company name. Can you orient us a little bit about Deloitte's manufacturing experience and what they're offering to the industry?
Sure. Yeah. So, to click it down a few levels, Deloitte has a very large consulting practice, right? A lot of folks would probably know us from working in IT systems and back office type systems, SAP transformations and things like that. That work extended over time into supply chain operations and network optimization. And that's really where manufacturing sits for Deloitte, right? If you think about the make portion of supply chain, it sits right in the middle. I think, so this was before my time, but I'll tell the story anyway. About 8 years ago, the firm made a very focused effort and very large investment, hundreds of millions of dollars, to grow a smart manufacturing capability and offering inside of the firm. And so we're 8 years down the road. It's a very large and stable part of our portfolio offering. Again, we serve all industries, and I would say, we normally kind of approach it with the full spectrum of services, right? We do advisory and strategy work for clients that are looking to transform their factories and their operations and the way they approach, human capital as a part of that. We do a lot of implementation work, programmatic rollout of these types of technologies and solutions, proof of concept, proof of value. And then we also do, and this is more of a growth area, we're doing more operate structures, right? Where we might be serving as like a digital foundry for a client to help them fuel their innovation and proof of concept funnel. We might operate some of their OT services and systems and maintenance support. We might provide, staff augmentation and expertise as well around those types of solutions. So all over the map, but we play very heavily here in the smart manufacturing world.
Well, that is certainly interesting. It's great to learn and understand everything that Deloitte has to offer. And coming off of conference season in the spring, the very large conference, HMI, Hanover Messe in Germany, probably the largest conference devoted to manufacturing, and all the various white papers that are out there now. We're just hearing and seeing a lot about software-defined manufacturing. It might be a new term to some of our listeners out there. It certainly was a new term to me until pretty recently. Could you define what that is a little bit for us?
Sure. And so Deloitte didn't define or invent the term software-defined manufacturing. It has been showing up in some other places, but it is one that we gravitate towards. Maybe a good parallel would be, for those that are familiar, there's been trends in software-defined networking and software-defined storage, right? With this whole concept that as you need to provision physical networking switches or storage locations for compute, to do it programmatically, right? To do it with software so that you can dynamically change that physical environment. We also see it kind of show up in software-defined vehicles, right? With some of the more progressive vendors doing over-the-air updates to give that physical car or that OEM piece of equipment more features than it started with on day one. And so if we map that to manufacturing, very simply, it's how can we get away from these rigid hardware-based systems so that we are consistently putting new dynamic functionality into the equipment that controls the process, making our manufacturing processes more dynamic, more evergreen, and more safe, right? More cyber secure and safe.
Yeah. When you were originally talking about making changes to machines, software changes that change their performance, my mind immediately went to Tesla. That was like one of the cool things. I wasn't really aware of that when Tesla first came out, but from day one, those cars were designed to receive over-the-air updates that would, when I think about receiving updates, software updates, I think it's going to, affect my computer. But here now we're talking about software updates that actually affect a machine, and it's certainly not just limited to cars, but machines that are used in the manufacturing process. Is that something you can elaborate on anymore?
Yeah, I mean that concept's been coming up more frequently with that analogy specifically, and I think the important part there is that it was intentional, right? When this didn't just happen overnight. This wasn't just any car. This wasn't just any piece of appliance that was part of the car that allowed this to happen. This was very well thought out from the way that they structured the infrastructure and the connectivity and the interaction, as part of developing that automobile. And so, to just keep in mind that there is a philosophical change in how people are approaching manufacturing and thinking about really the life cycle of what's going to happen with the physical asset, and how can software play a role in making sure that the life cycle of that product and that machine and that process, continue to create outsized value.
Yeah, so like more day one type considerations. Sounds like a very promising and powerful notion in the industry. A shift in a shift in design of the products as well as the manufacturing of those products, wouldn't you say?
Mm-hmm. Totally agree. Yeah, I would say it comes with the design, but it just comes with careful coordination, right, at how things happen.
Yeah, that brings me back to my manufacturing days as a manufacturing engineer, and there still were updates being put in vanilla envelopes and being sent off to other parts of the company. All right, so digging in a little bit more to software-defined manufacturing and the particulars of it that impacts manufacturers to accomplish things like achieving business impact, responding faster to market trends, nailing their goals at enterprise scale. Can you touch on how that's possible with software-defined manufacturing?
Sure. So the way that I see things, and especially like some of the more recent client interactions we've had over the last couple of years, a lot of the challenges are the same, right? They want to be more performant in the systems they build. They want to have higher levels of quality. They want to do it with less resources and cost. They want to do it in a
getting
safer
more
way.
out of their assets that they've
Right.
invested
Yeah,
in.
that's still the same thing that manufacturers have been wanting to do for a long time. I think the world is become more dynamic. So we're seeing a lot more change, a lot more possibility opening up through technology. We're seeing a lot of increased competition in the world that's also driving some of that change. And I think where in the past we might have said we need to have flexible manufacturing, this is really taking it to that next level, right? And saying, how can we be flexible by design? How can we add value by design in doing this? And so just to kind of pull back to that value lever, right? It's the same things, but I think the pedal is down, right? To keep going with the car analogy. People want to do more, they want to scale wider, and they need to do it faster, right?
Yeah. All right. So, are there any examples you can give of software-defined manufacturing that you personally have implemented at various customer sites?
Yeah. So, I mean, some more generic examples are thinking maybe around like a PLC application, right? PLCs are the automation controllers that control the equipment. Those are predominantly done with proprietary software. They may or may not be connected well to the network. They're certainly not something that is often left open to make change while the line is running, right? And so one example is there's folks looking at creating soft PLCs, right? Soft PLCs written on real-time operating systems that are open and but secure by design, so that you can embed, control, and change without taking the line down, as an example. Another like sort of representative example might be these abstraction layers that people are providing across robot programming languages. So as people put more and more robots, more and more automation on the line, there's a lot of different proprietary languages that sit there, and you can't write a custom application that talks to everyone, and you certainly can't hire people to know all 20 languages. So could you put an abstracted layer on top that interprets what I want to do down to the specific piece of hardware that lives there? That's a good analogy.
So Brian, can you give some examples of how software-defined manufacturing have had impact on customer operations?
Sure. So one example is the client that we work with together. So it's a global logistics company. Their whole need was to unlock capacity in their network. They wanted to basically sort more boxes with the same number of facilities. And so we looked at a predictive maintenance use case, originally targeted at many facilities. Ultimately, right now, we are at just north of 40 facilities where we have their entire facilities extracting PLC data, IoT data from vibration sensors and bearing health sensors, package scan tunnels, and ultimately running that through a whole host of machine learning models up in the cloud, and then driving predictive work orders into their EAM and CMS system, right? And so that was a really interesting project. And I think that when we started it, when we did the pilot at a single site, we had a different architecture. We had largely a SCADA architecture, right? We pulled all the data into an on-premise SCADA and we pushed it to the cloud. And we started to look at, well, that might not be very flexible as we want to keep adding additional analytical capability. We want to maybe use that data in other ways. Also, we were going to have 40 plus SCADA systems that we'd have to manage, which was doable, but it didn't feel good. It didn't feel right. So we did relook at the architecture. It was actually where we introduced ThingWorx Kepware Server as an OPC UA layer. And so we got all of that PLC data coming in one format. To give you like an order of scale, we're probably doing somewhere in the neighborhood of, it's single digit billions of tag reads per day per site for that. We don't take it all forward. We look for change, and we're not being egregious with how much data goes forward, but it's a lot of data, right? It's probably 100,000 tags, right, in total per site that we're using as part of this solution. And so, thinking about how we sort of abstract that data with Kepware, we brought it together with other pieces of data in a data hub architecture. And then we used a centralized MQTT broker that actually sits in their data center. So it was a central point. We wanted some flexibility in how we move it to the cloud. And we also really liked that sort of publish and subscribe architecture, so that if we add more data into that, it'll just start publishing to the cloud. It'll just be available to other systems that want to take advantage of it. That's the concept of software-defined manufacturing. It's kind of building things once and leveraging it multiple times, and building it in a structured way so that people can kind of keep coming back to that.
Cool. Well, you did mention Kepware and in that we are in the industrial connectivity space. I'm curious if, enterprise-wide industrial connectivity, is that part of an overall software-defined manufacturing strategy?
I think it's arguably one of the most important. So if we think about it, like that industrial data is the data that's going to and from the physical equipment, right? One of the core pieces of that PLC that we talk about, if you're using a PLC, is its input from sensors into the PLC and going back out into actuation devices or something, right? So that's our location where we touch the real world. And I think what we all know for folks that work in the industry is like that world is very messy, right? It's very heterogeneous. It's installed over decades, and it's largely configured by humans in proprietary languages, current state, right? And so the ability right there with something like is we start to control what we can control. We can't always guide our OEM equipment builders and our providers to give us exactly the data that we need in exactly the form that we want. But once we receive it there, we can start to clean it up. And cleaning it up at the edge is super helpful, right? At making that data more accessible and standardized.
Exactly. So I don't know if you're aware, but Kepware has been providing industrial connectivity for more than 25 years. So that's not a new concept to the industry. Mm-hmm. But I love how you talk about taking the abstraction away to deal with the proprietary protocols and so forth. And historically, Kepware has been deployed, as we would say, in a point solution type fashion, where you have a need for an application that needs data from a certain machine. A control engineer, maybe like yourself when you were growing up, mm-hmm. Found out about Kepware and found out that it had the ability to translate that protocol and basically communicate with that machine. We called that a point solution. One license of Kepware to provide data to a specific application. But now, in this larger play of digital transformation, that point solution deployment of Kepware is certainly not what I think the IT side of the house is looking for as far as a solution goes for enterprise-wide connectivity. Do you have any insight to that?
Yeah, maybe like an analogy would help. I think if we're connecting one machine to one system, I'm going to take the path of least resistance. I'm going to put as few systems in place there just to go from that system to that system. And I think engineers largely have designed that way. This MES platform can take this protocol up. It doesn't support this protocol, so maybe I put a converter in between. Where we sit today is we have a lot of these point-to-point solutions. Sometimes people will use something like Kepware. Sometimes people will use a physical converter. Sometimes people will push something through one system and then funnel it up to another system. And what you end up with is really it is a bit of a spider web that sort of sits out there. And so where we are today in sort of this industry 4.0 journey is people are building these really valuable applications and they're working very hard on a pilot area. And then when they get to scale, they realize because of my infrastructure challenges and the way I've done things in the past, everything's going to be hard, right? And so I think that drives towards this, if you put more layers of standardization in between, maybe it's an OPC UA server more broadly, like that becomes your connectivity strategy. maybe it is some type of a data hub architecture or an MQTT broker. You can start to put all of your data in one place so that now when I build an application, it's going to, apply to all of that really messy equipment because I've kind of done the middleware work, if that makes sense.
Yeah, no, totally. We were talking, specifically about a particular customer project and the ones in general that you've worked on. I think there's just always so much to learn while we help customers go through their journeys and so forth. Do you have any thoughts on other topics like facilitating change management or other gotchas that might be out there that our listeners should be considering?
Yeah, so I would say change management and adoption are probably the single most important thing. And I think that includes frontline workers for sure, the engineers that are going to support things, but also the leadership and sort of that sort of level as well, the people who might hold the purse strings. Sometimes I think, what we're largely talking about here is different ways of working. We're asking leaders to probably put real dollars towards infrastructure investments, process change, data modeling, enterprise data modeling. Those on their surface don't bring value, right? And so bringing them along for that change and adoption journey and that understanding journey of why is it important to do that is just as important as bringing your frontline workers forward with how you might use new and emerging technologies and how does that impact your day to day. So I think everyone's along for a journey, probably in some different ways, but change and adoption is super important.
Yeah, Brian, there's just so much to learn from customer projects, and it is great to say that both you and your clients are learning as you go through these journeys. There's so much obviously that you're learning with this software-defined manufacturing. Do you have any best practices or guidelines that you'd like to share for anyone out there that is looking to go on a similar journey?
Sure. So, most clients have some type of a technology roadmap or a industry 4.0 roadmap at this point, and it might span 3 to 5, 10 years, right? And so I think there's a lot of these capabilities that clients want to unlock, which is going to translate to that value. What I would say is consider how the way you approach data and the processes of how you're going to set up that capability are part of that conversation, right? To put it maybe a little differently is when you build these technologies, we're not designing for pilots, we're designing for long life cycles of technology, right? And so if I layer on all of this extra complexity of augmented reality and machine learning and analytics, how am I going to maintain that? And how am I going to improve that over time? It's probably going to require that you look at, do I have the right infrastructure and connectivity to be able to facilitate that life cycle and that frequent change and update? Do I have am I thinking about data the right way? Do I have the right data modeled? Do I have it in context? Is it accessible and standardized in a way that we can apply a bunch of different use cases to that same really valuable underlying data? And then number 3, do I have the right processes that I'm thinking about? Am I thinking about deploying these in sort of an ops type format? Do I have a way to deploy new code? Do I have a way to do data ops, do ML ops, do my, cyber and security ops in a way that all of that's continuing to move forward? Those are big considerations. And I think, those are the things that are going to make sure that those technology investments that sit on that roadmap continue out into the future as foundational technologies.
Yeah, on the first episode of this podcast series, we had Abby E on, the general manager of Kepware, on, and we did talk a little bit about what we were calling the sexy applications, the augmented reality, you had said, the machine learning and so forth. And can you imagine if each one of those applications had to, have the communications, the industrial connectivity be a part of their overall offering, and how, like you said, a spider web, it would just be really messy from a data standpoint, and how often we're getting better, the industry's getting better, but typically like getting the data was kind of like the last consideration. The more interesting use cases and so forth is what was the forefront of everyone's minds as they got started. And then they realized like, oh shoot, like how are we going to actually bring this data? It's not just for this one application, like to your point. Let's think about how are we going to have this data be available for anything that we're deploying right now, things for the future and so forth. So I think that abstraction layer that you pointed out becomes more and more useful over time.
Yeah, and you got me thinking, and I was just with a client today that pulled on this, and like virtual reality and assisted reality and, X reality, like that's a really good use case. It's a hard use case. I think, and you guys know it very well. And PTC's been at the forefront there for a long time, but I think mass adoption in manufacturing, that's probably an area that's slower than what you guys would like to see. And I think we can apply the exact same things here. Like, what happens when the CAD model changes and the physical process changes? How do we adapt that VR application to support that without having to do a whole bunch of extra engineering? Right? Like, what happens when we get another machine that shows up and they use a different platform or a different program, right? Can we automatically use that? Or do we have to kind of jump through some hoops to get it there? Is there friction in the system? And so I'm starting to actually see hints where the way that we handle 3D models in sort of an enterprise way, in the way that we handle data in the enterprise way, they're getting a lot better to start to enable these enterprise-wide, unlimited reality as we sort of deem it inside of Deloitte, but how those applications might come through and actually build scaled value, right? Versus I think we're still pretty emergent on a lot of the operational use cases there.
Well, that's interesting. You bring up like 3D modeling and so forth, where, as a design engineer, maybe is like designing the machine that they are having these thoughts in their minds from day one as they design that machine and the 3D modeling essentially, so that it can, modify over time and serve the market to its needs. Well, software-defined manufacturing is obviously an interesting topic and one that's here to stay and continue to expand. Brian, thank you. Deloitte, thank you for being with us and sharing your insights and expertise around this topic.
Yep. Thank you, Steve. This was great. Really enjoyed it.
Very good. Thank you, all of our listeners out there. I'm Steve Sponseller for The Edge of Industry. I hope you all have a great day.
Thank you for listening to the Edge of Industry podcast, brought to you by PTC Kepware. If you enjoyed this episode, please subscribe wherever you listen. And please leave a rating or a review. Be sure to check out other episodes to hear new perspectives at ptc.com/edgeofindustry.